As the title of this exercise suggests, the focus of today's lesson is purely around the gradient. We're going to be introduced to this for the first time, so there might be a lot of new concepts, but hopefully by the end of this, we can define a type of gradient and find a gradient from a graph. So this whole video is going to be about what gradient is and how there can be different gradients. But the first thing we really want to focus on is the fact that a gradient is the slope. So how steep is this slope? So we have positive gradients, which you can now see on your screen. And the reason why they're positive is because we're always looking from left to right. And from left to right, all three of these lines are going upwards, which means that these are positive gradients. Negative gradients look like this. It means as we look from left to right, they are working their way down. So it's almost like positive gradients are uphill and negative gradients are downhill. Just another way to look at this, gradients are measured from left to right, and positive gradients are the ones that are working their way up when we go from left to right, and negative gradients are the ones working their way down. So the gradient is actually a measure of the slope. So we can put a number to how steep this slope is. Or how not steep it is. Maybe it's flat. But there is a number that will help us understand which slope is steeper than the other. So the first thing we're going to look at is, again, there's all these different types of positive gradients we can have, but this is the one that we're going to focus on. And this line is called y equals 2x plus 1. So to find the gradient of this line, we need to determine the change in y when x increases by 1. So when x goes from 1 to 2, and you can see here with those arrows, x goes from 1 to 2, that means our line is going from here to here, okay? What's happening to our y values? Y increases from 3 to 5, and you can see there that I've circled that. So as x goes up by 1, which is from 1 to 2, y increases from 3 to 5. Let's look at another pair of points. Let's say when x goes from 0 to 1. So I'm going to point to them here with my arrows. The y values increase from 1 to 3. And I'll circle these here. Okay, so now that we can see how x changes and y changes when we pick 2 points, let's try and create what we call a gradient. And you can see at the top of your screen that the gradient is the change in y divided by the change in x. But before we do that, let's look at it again. Here we have x increasing from 0 to 1 and y increasing from 1 to 3. We also looked at what happens when x increases from 1 to 2, which looks like that, and y would increase from 3 to 5. But how do we actually find what the gradient is? How do we work it out? So now that we know how they change, we know that gradient equals rise over run. And this is something we're looking at for the very first time. So the rise is how far up or down did it go? And the run is how far left to right. So for the green one in the example, we've got the rise over run. So we've got the rise being how far up and down, okay? And we can see that y increases from 1 to 3. So it's gone up 2, okay? So our top number should be plus 2 because it's gone up. What about x, which is our run? Our run means that x has increased from 0 to 1, which means it's gone from the left to the right 1 unit, which means it's plus 1. So plus 2 divided by plus 1 gives us an answer of 2. So this is our gradient for this line. But if we look at the other pair of points that we looked at, which are in orange, okay, we should still get the same gradient because we're still looking at the same line. Okay, so the rise is going from 3 to 5. So if you think about that, we're going from 3 to 5, which means we've jumped up 2 values. Okay, and x has increased from 1 to 2, which means we've increased the run by 1 value, which also means that our rise over run is 2 divided by 1. So we've got the same gradient. The gradient of this line is 2. So let's look at a different line with a different gradient. Okay, so here we have slightly less steep, but we're going to pick 2 points. Here we have where x equals 3 and y equals 1, and here we have where x equals 0 and y equals -1. So the first thing we want to figure out is how far has x increased. So it's traveled from x equals 0 to x equals 3, and the y value has gone from -1 to 1, so it's also increased. We remember that the gradient equals rise over run, and the rise is how far up or down, and the run is how far left to right, and it has gone up 2 and right 3. So that means our gradient for this line here is 2 over 3. So now let's look at a slightly different example where the gradient is going downwards, where it's a negative gradient. Remembering, we're always looking from left to right. So let's pick 2 points. Here, where x equals 2 and y equals 0, and here, where x equals 1 and y equals 2. So let's see first how far left to right it has gone. X has traveled from x equals 1 to x equals 2, and y now decreases because we're going down. So we're not increasing anymore, we are decreasing. And we've gone from the point where y equals 2 to the point where y equals 0. So we've gone down 2. Okay, and now we can try and figure out what our gradient is. So how far up or down divided by how far left to right. Now we know that we're going down here, so our number that tells us how far up or down should be a negative number. Because we've gone down 2, we should have -2. And our x value or our run value should always be positive because we're always going from left to right. And we've gone 1 value from left to right, which means our rise is -2 and our run is +1. This means that our gradient for this line is -2. So just to sum up what the gradient is, it's a measure of the slope. And it is the increase in y as x increases by 1. It is, as we've seen, rise over run is the change in y divided by the change in x. And here is an example of a positive gradient. So we find the rise has gone from up 4. So as you can see here, it's gone from here to here, which is a vertical increase of 4. And our run is how far it's gone from the left to the right. So we've just picked 2 points and it's gone from here to here, which means it has gone 2 to the right. So 4 divided by 2 ends up being 2. What's happened when we find the negative gradient? Okay, so we've got a point here, okay, and we remember that the gradient is rise over run, okay, and we see that the rise is going downwards, so we know it must be a negative number. It's gone down 3, and the run is always positive. It's gone across 2, so it's -3 over 2, and that is our gradient. Rise over run, rise is change in y, and run is change in x. Final point is that the run is always considered to be positive when moving from left to right. So what is the gradient if it was just got a vertical line that just goes straight up or straight down? Well, let's just work it out like we normally would and see what happens. So here we have, let's just say it's gone from y equals 1 to y equals 5. Well, y increases from 1 to 5. And what happens to the x value? Well, it doesn't increase and it doesn't decrease, it just stays the same. So you could say that the rise is 5 and the run, well, it hasn't run at all, it hasn't gone any distance, it's still staying in line. So the run could be 0. So we can say that the gradient of this line is 5 over 0. Let's just say that we picked another 2 random points and we saw that the rise was from 0 to 2, and of course the run, or the x change, does not increase. So again, we can pick another 2 points and we can say that the rise over run, in this case here, is 2 over 0. But it doesn't really matter which way you put it, because anything divided by 0, if you grab your calculator and check, will always be undefined. So if you do 5 divided by 0 or 2 divided by 0, your calculator will come up with some sort of error, or it will say undefined. Let's do the same thing here for a horizontal line. So let's just pick 2 points. Let's say that this horizontal line has traveled from x equals -2 to 1, but y doesn't increase. Okay, so what does that mean? We can say that our rise over run, well, if y doesn't increase or decrease, we can just say that the rise is 0, and the run, well, we can see that it's taken 3 units to go from -2 to 1. And if you can't see that, then just look at your screen right here, where I've moved 1 unit here, 2 units here, and 3 units there. So that means that our rise is 0 and our run is 3. Or we could pick another set of points, okay, and we can say that here we have our rise again not going up or down, being 0, and our run going from -3 to -1. Okay, so that means that our run is 2. Okay, and that means that our rise is 0 divided by 2, which anytime we have a 0 divided by a number, you'll always get 0. And if you don't believe me, put a 0 in your calculator, divide it by any other number you want, and you'll always get a 0. So in other words, whenever you see a vertical line, doesn't matter where this vertical line is, okay, the gradient is always going to be undefined. And the way I like to think about this is, try walking up a building. You can't physically do this. And that's what makes me think, and that's what makes me remember that this is always undefined. And this is a picture that might help you remember that. When it comes to horizontal lines, okay, think about just walking on a flat surface. So your gradient is really easy. You have no difficulty whatsoever. It's just like walking on flat ground, which means the gradient is always going to be 0. And I always think about people just walking on a flat, easy walk with no difficulty whatsoever.